So now that we've just talked about the assignment a bit, let's get to content. So this is basically where we left off, I believe, right? Correct me if I'm wrong. You know, this is typically what you see in your evolutionary algorithm. You hit run, and if you plot like the best fitness over time and your population's average fitness over time, you'll get a curve that looks something like this, right? You can see it grow, it learns really fast, and then it starts to get slower and harder and harder and harder to get any better. Depending on the shape of this curve, it might tell you a few things. It could give you some insight in how you can maybe change some of your hyperparameters. Let it run longer, let it run a little less, give it a bigger population. It stagnates early, crank up mutation, et cetera, et cetera, et cetera. Now, gaining an intuition on how to look at these plots and it giving you an idea of like how you can change your hyperparameters, that's something you kind of learn, like you get a feel for as you get experience with evolutionary algorithms and your particular problem, because they all kind of act their own little way. But, you know, you get something like this. Fitness improves, but it starts to slow. Its improvement starts to slow. All right, final note. Whenever you want to solve a problem, I've said this before, I'm going to say it again. Let's make sure the recording's happening, because last time it didn't happen. Good. You don't want to use evolutionary algorithms. Like that means if you're in a situation where you really have to use it, that sucks. Because these are very difficult problems that the problems are really hard in and of themselves, and the algorithms and strategies we have for solving these types of problems are the best we've got. They're like, you have to concede a lot in order to use these types of algorithms. This isn't just evolutionary algorithms, these are like the beefy forms, your computational intelligence, like the heavy-duty AI that we use. You don't want to use these things if you don't have to. They're really bad because, you know, they're very computationally expensive, they overfit, it's hard to understand why it came up with what they do, and often it's not going to find the best solution to a problem. I mean, and none of these things are really the algorithm's fault. I mean, this is just the nature of the beast. But we accept the fact that there are some problems where, yeah, we've got no tractable like way to find a solution, right? It's unrealistic to say, well, let's go find the best solution. And sometimes, yeah, finding the best solution is a waste of, that is a stupid endeavor. When all else fails, that's when we use these tools, when we've got no other way to do it. Now, one thing that's nice about evolutionary computation compared to other forms of computational intelligence is it's population-based. Meaning, you know, when I hit run on my neural network and it's done learning and I go to test it, like I've got one final result. With evolutionary algorithm, like what's my population? I don't know, 100? I've got 100 potential solutions. They're all going to be similar, but they're going to be a little bit different. So if I'm unhappy with one, I can go try, like when I'm done, I've got a lot of solutions kicking around, which is kind of nice. Evolutionary algorithms and other forms of computational intelligence, but evolutionary algorithms really work surprisingly well with noisy data, and they work really well on large non-continuous search spaces, which is nice as well. And one thing that I really like about evolutionary algorithms, a lot of people really like about evolutionary algorithms, there are people that will dedicate their lives to TSP. That's not a joke. They will. Like, that's what they study, right? And the reason, by the way, when we talk about things like TSP, and I say like toy problem, I'm not saying TSP isn't interesting. It's very interesting, and like we just briefly talked about, without getting too into the weeds, all of the problems that are similarly difficult are all actually slightly different variations and formulations of the exact same problem. So if you're studying TSP, you're actually studying all of the problems that are like TSP. It's just we like TSP because it's easy to wrap our head around in terms of what the problem is and what a solution is and what makes a good solution. But finding a good solution, no, that's tough. And knowing if a solution is the best one, yeah, you're not gonna. So if there's someone that can like dedicate their lives to TSP, like imagine like if I gave anyone an instance, imagine the years of expertise that they're going to draw on to come up with a good solution to any instance of a TSP problem. And by the way, maybe I'm explaining this poorly, but how many of you knew anything about TSP before like a week and a half ago? How many of you had no idea what really TSP was before a week and a half ago, right? And of those that said, yeah, you knew what TSP was, okay, you knew what it was, you knew what the definition of it was, but how much time did you spend on it, right? Don't try to impress me, because I know the answer is you haven't, right? And that's entirely fine. No, stop it. Stop. This is not a discussion. That's nonsense. So when we have situations like this, like, okay, you said you're done TSP, like you finished your assignment, right? So how many hours would you say you put into your assignment? 4. 4 hours. I'm willing to bet you probably got pretty damn good solutions.
Yeah, I think we're good.
Yeah, you're getting pretty good. So it took you like 4 hours to get decent solutions to a goddamn hard problem. You didn't need to be an expert. You didn't need to have years of experience to do this. You didn't need to know shit all. You want to dedicate your life now? The good news is you don't. You got a GA. You need to know dick all in order to get good results, which is fantastic. It requires minimal expertise in any domain in order to get really good results to problems, which is another really big benefit of these types of algorithms. You don't need to know anything. You need to know minimal. That's not to say that the more you know, the better you can get. You could start to exploit things that you know and work it into your algorithms to get even better results. But you don't need to in order to get good results. So it requires minimal expertise, which is fantastic. At the end of the day, this is like perhaps kind of like a silly plot. But imagine I'm trying to represent all possible problems. And I'm looking for all possible solutions. I could do a random search. I'm going to get shit results for everything. If I'm someone that dedicates my life to these problems, maybe I can come up with a solution that's really good, right? But a solution that's really good for TSP, like a strategy that's really good for TSP, is probably only going to be really good at TSP and maybe a couple of other similar things, where a GA is just going to do pretty damn well in general, which is nice. And this isn't just for genetic algorithms. This is for several forms of computational intelligence. All right, for next class, TBD. There's a lot of TBDs at the end of each of these topics. So has anyone figured out what they want to do for the next class? All right. Any questions about that? So it's funny. We're now like, what, 3 weeks in? 4 weeks, almost 4 weeks in, and we finally hit the overview topic. There's a lot of context we have to have in order for this stuff to kind of make sense. Now, one thing I wanted to do, raise your hand if you have decent experience with GitHub. Half a person, 1.5 persons. All right, cool, perfect. We're going to do a little bit GitHub. Now, some of you in here, I know, raise your hand if you already have your topic selected, like officially for your lecture. You do? Perfect. Raise your hand if you haven't officially picked it yet, but you know what you want to pick, you just haven't told me yet. You? Perfect. We're going to use you as an example. And you get to follow along. Actually, I want everyone to follow along more or less, but with the last little bit, we're going to have you, I'll show you the process. All right, here's what we're going to do. Okay, so this is assuming, okay, if you haven't already, go to GitHub. Actually, no, here, it'll be easier if we do this. CSCI 340. If you go here, and you can find a link directly to the GitHub page. So this is on the index page. You go directly here. This is all of the course content. This website, this GitHub page has actions that actually goes. In fact, there might be some pull requests today because, yeah, NumPy's been updated. Great. The Devin Already submitted a pull request, so very good. This is where everything is. There's the resources in here. In here, there's like, okay, TSP. In here, here's all the instances that I want you to download and play with, right? This is all of the course content. Here's the site. If you go through this, you can find literally all of the stuff to build the website. Here's the source code. Here's the test for the source code, et cetera, et cetera, et cetera. This is effectively all of the course content. And from here, whenever a pull request is submitted and approved and merged into the main branch, the course website goes and updates automatically. It's great. It's fantastic. So that means if you ever make a change, like if you ever find a typo or you want to do something, you could submit a pull request, and if it gets accepted and merged, it goes live to the website. I mean, it takes like 3 minutes for it to go live, but it does, which is pretty cool. All right, so if you haven't already, you're going to want to go, I think it's here, and then fork. There's a fork. You're going to want to fork the project if you haven't already. And what that does is it effectively like makes like a fork of the project. It's kind of like making a copy of the project that belongs to you, but your copy is inextricably connected to the main one. And you're going to want to constantly like fetch and update your branch, like your fork with the main fork. And whenever you make a change, you can go back into the main fork, which is kind of cool. So if you haven't already, make a fork. And if you haven't already, download GitHub Desktop. If you're on Windows. I don't know if there, I think we found out last time there is a Mac version. Cool. Okay, all right, let's remove this and we'll start again. Perfect. You can use GitHub Desktop. If you don't like GitHub Desktop, you prefer using like Bash or Terminal or whatever, by all means go for it. That's how usually I prefer to do it. But a lot of people like GitHub Desktop because it's very visual and it's a little easier to understand. GitHub, the terminal-based one, you kind of have to just have experience with it. Again, back in my day, we didn't have anything nice like this. Cool. So assuming you're here, you're going to want to go and you're going to want to, okay, clone a repo from the internet. Clone means like make a copy from the online repo, like your online thing. All of your projects are on GitHub. And if you want to have a copy of that on your computer, you clone it. So we're going to clone it and we're going to find the one that you want. Now the one I am looking for is for evolutionary computation. Okay, so I've selected it. Where am I going to put it? I'm just going to put it on my desktop because I like my desktop because I'm lazy. And I'm going to hit clone. And it'll take a moment. Not too long, but it'll take a moment. Perfect. Perfect. There we go. I've got it. And now if I go to my desktop, this is back. It was there moments ago. I deleted it. And now I just cloned it again for the sake of showing you. Cool? Cool. If you go here, you will see all of the same thing from the GitHub page on your computer in this file or folder. Right? We can go to resources. There's the TSP thing. There's all the stuff. Right? There we go. By the way, there's this like proprietary TSP lib format that if you go and you download like the TSP instances, they're going to come in this TSP lib format from like 20 years ago. It's goddamn awful. So that's why I went and I updated them to be JSON, which if you're not familiar with JSON, they're pretty good. It's effectively like a dictionary, which is really nice. We like that. JSON's great. Anyways, there we go. Now, I personally like PyCharm, so I'm going to open up PyCharm. Oop. Now, I might get lucky, and it may have been, it may open evolutionary computation already. Oh. But I had just updated it. Yeah, sure. There's no valid. What are you talking about? Oh no. All right, well.
The time you want to show everyone.
Yeah, go figure. Please stay open. Damn it. All right, fine. Lame. All right, well, we don't need PyCharm. We could just use Notepad. But it's kind of shitty. It'd be nice if you open up in PyCharm. It's a little nicer because it does some formatting for you and whatnot, but whatever. Okay, cool. So, is everything kind of like set and ready to go?
I think.
You think, okay, cool. So here's what I want you to do. You're going to say, I know what I want to do. This could be like, I found a typo. I want to make a new topic and impress everybody. Cool, whatever, I don't care. But let's say right now, I know what topic I want to do. And because I want to impress James, I'm not going to go email him saying, hey, can I do this topic? I'm going to submit a pull request just taking the topic I want. Perfect. So here's what you're going to do. First things first, you're going to say, well, I'm not a terrible human being, so I'm going to go here and create a new branch. Okay? And your branch is going to be called like student. You can call it whatever you want, but a nice name like student lecture, what, and what did you want? Like what?
I think
Neuroevolution. So you'd call it something like this, okay? You can call it whatever you want, but this is kind of like the format I usually go. I go like, okay, what's it about, dash, anything more specific. Let's try that again. You go here, new branch.
I'm on the terminal, so it's
Oh.
just git branch.
Yeah, what you're going to want to do is you can do git branch. The easiest thing to do is like git checkout -b. Yeah. Space, and then you type in the name. I'm going to create the branch locally here just so everyone can follow along. Did it work?
Yeah, no, I have to clone because.
Okay, cool. For those of you that do like using terminal, it's easier. The reason I said do checkout -b, if you're making a new branch and you immediately want to check it out, you can do that. It's nice. Otherwise, you create the branch and then you check it out, which is fine. It's just, it's kind of nice to do it in one shot.
It's a capital B.
No, lowercase b, lowercase b.
And then just the name of the branch.
Yeah,
Okay.
yeah. And make sure you're in the Git working directory.
Yeah.
Okay, perfect. Perfect. Now type in git space status just to make sure you are, in fact, everything looks good.
On branch student.
Perfect, perfect. Then you're going to go navigate to. Now, you just have to know where this is. You could kind of get a sense of where it is if you were on the course website. Let's go here. Student lecture. You can kind of see like, oh, student lectures dash description. So if you go here, okay, site, you will see, oh, student lectures. Oh, description, perfect. Now this is an RST file, restructured text. It's like the markdown for like Sphinx stuff. It's a whole thing. Cool. So I'm opening up the file I want to edit. I'm going to scroll down to, where is it? Here we go. You wanted neuroevolution. Neuroevolution. Taken. There. Just, yeah. You don't need to put your name. You can just say taken, and then we know. Oh, okay. It's spoken for. Okay. When you're ready, you just save that file. And now here, if you're in GitHub Desktop, it'll show you like, oh, hey, you changed this file, and that's what changed, right? So then here, you're going to want to commit that change. For you, type in git space status, and it'll probably show you like, that file's changed. Yes. Perfect. And if you want to see, you could be like diff, but you know what it is. So you could say git.add, then space tab, enter. It'll just autocomplete for you.
Git.add description.rst, right?
Add The student lectures dash slash description. Yeah. Yeah. Okay. Perfect. Okay, I'm going to go add a little, and then after you've added it, you do git commit. Do like -m so you can add like a message. I want it. There, I don't know. Put whatever commit message you want in there. If you don't do the -m, it'll like have a pop-up that'll be like, okay, type in your description. You just want like a quick little description, so it's easy to do it in line. So I commit. There. Now before I carry on, I'm going to come have a look at what you got just because I don't want to make sure we're like out of sync before we get to the next part, the important part. So let's have a look.
Did I do the add right? Just get add or I missed something there?
Git add description. It depends on where you were. Yeah, okay. Yep, git add, git status, on branch, student. So git add. I'm worried that nothing. Did you? Okay, git add. Taken PW. Oh.
I can double check the.
Yeah, let's go look at the.
I just use Nano.
Oh, you were using Nano?
Yeah.
Okay, open it back up. DES?
Yeah, I know how to spell.
Yeah, neither do I. DES. Looks like you have DIS.
Oh,
DES.
Okay, yeah.
There we go. And then neuroevolution, yeah, you have taken. So why is it not? Control X? Huh.
I can just get the.
Whatever.
The G.
Let's check. Maybe it's, who knows. Okay. So now what you're gonna want, git push origin. What did you call the branch, student?
Yeah.
Hmm.
It's because I wasn't working in the
Yeah, I don't know. There we go. Unable to access. Access denied. Well, let's pretend it worked. Does anyone else? I'm going to recommend maybe you switch to using GitHub Desktop. So here we go. Whatever. There we go. I'm here. Yeah. And I made the change and I pushed it. If this was you, right, what you would then see is you go to the website and you will see, did I not push it? Publish branch. Okay. I hit publish branch. That's to push it out.
It looks like it takes a sec because I've just pushed onto it. I haven't seen it.
Okay, let's check it out. Okay. So there we go. For me, student lecture neuro. So now you've pushed it, but you need to create what we call a pull request, which is basically saying, I've made a change, and I want you to have a look at it and see if you're happy with it or not. So create pull request. And we're going to do, you will of course read the contribution guide and follow my little contribution rules. And what do we have here? set new revolution to taken. Okay, we don't need that. No related PRs. What a student wants to do. And then why. Some of these are redundant and unnecessary. They're just very general catch-all. Like why? Well, it's obvious. How? It's obvious. Testing? Nah. We don't need to test it. It's obviously such a small thing, and we're good to go. If I had PyCharm, I would show you how it is easy to test it, but I'm not going to bother doing that right now. You can't set a label, but I'll do it anyways. And then you create the pull request. Okay? And then I see, and you said you were doing one right now?
Yeah.
Perfect. You're trying, okay, yeah. So there we go. And then this creates the pull request. So let's assume it wasn't me that just submitted a pull request to myself. Students would come in, and hopefully we'll see yours come through, and then I can show you. What happens is when you submit it, I've got a few little like tests that will run automatically. Now, I believe that if it's the first time you've submitted a pull request to the repo, it won't run the tests by default. But as soon as I say like, yeah, every subsequent one you do, it'll automatically run the tests, which is nice. It just prevents like randoms from spamming and wasting resources, right? That's all. But once it's approved, once you've like been allowed to have your tests run, then the test will run automatically. And then this just gives me a bit of a sanity check that says like, oh, okay, well they didn't break anything enough that these tests failed. There's no guarantee that you didn't break anything. But then what I would do is I would go like, oh, well, what did they do? Oh, okay, well, they just made this little change. That looks good. And I go like, oh, yeah. I can't approve my own. Damn it. All right. So kind of spoil. Oh, another one came in. Perfect. So this will work a little better. Dippy McSkippy has submitted a pull request. Now, usually what I would say in here, I'll make an example here. I want it, please. Cool. We would get rid of some of this stuff. Related PRs, no. I would like to do ant colony. Yeah, you know what? I'm just going to get rid of the excess. Oops, no, too much. I want to do that. Why? You know why. So anything that you don't want, you just get rid of. Testing, no. Additional notes, no. Okay, cool. So I'm just going to update that comment just so it's.
I like the email.
Yeah, me too. That was a nice touch. So I go look and go like, oh yeah, they set ant colony optimization to from that to, oh, taken. Nice. All right, cool. So I go here and go like, that looks good. Well done. There you go. I'm going to give you a little message, little, and then here we go. A little rocket ship. And there we go. Oh, and then yes, okay, approve and run. So I approved it before confirming that the test didn't fail, but I'm pretty sure you didn't break anything. It looks pretty safe to me. So let's just make sure these tests run. Well, they're running. And if you're curious, I mean, you can like click the details and you can see what it's doing. Like, oh, installing the dependencies, and it's going to verify format. Test sample code, it ran all the unit tests, and none of them failed. You didn't break anything. Huzzah, looks good. And then Sphinx, it makes sure the website's can build without crashing, which is always a good test. Perfect. Hey, they all pass. And then once they're passed, I can go here. Squash and merge. We don't need the description there. I'll hit this. And now, okay, now you can go and delete that branch if you want. Doesn't really matter. You can leave it. You can delete it. It doesn't really matter. Now we go. And is it not automatically running those tests, actions? Yeah, okay. So now what it's going to do is it's going to rerun those tests for whatever reason, and then it runs an additional little action here called deploy, which means go send it to the website to get updated. And let's go see. So here we're going to go 340. Student lectures. And we can see you picked ACO, Ant Colony Optimization, right? That's a fun one. I like that one. So it's running the deploy. Oh, deploy's done. Now it probably will take a moment. Oh, there we go. Look at that. Boom. You officially have made your contribution, just like Devin last week. Your contribution will forever be recorded in the annals of history. That Dippy McSkippy, hold on, crunching your latest data. Yeah. Come on. Has contributed to the content of Computer Science 340 for the sake of mankind. You've improved the world slightly. Well done. If this will load, we can confirm it. I don't know why. There we go. Okay. Let's see. Let's see. There you go. Look at that. Well done. Look at you. That's him. What's this? Let's go creep your web. Oh. Look at that. What did you do? One contribution. You forked the repo. And today, look at that. Look at that. Pardon? The Twitch link is there? Cool. Anyways, yeah, Twitch. Should I go there? Or should I not? I don't know. I can. Is it safe? Am I going to get in trouble? When did you stream last? Let's find out.
It would have been not last night, the night before. There's a VOD up for sure.
There's a VOD?
Yeah.
Oh,
I
Valorant.
hit that right click, right?
Yo,
And
I
then I
have to
hit two other
subscribe,
dots,
follow.
78 damage.
Oh, I have to log in. Oh, man. No. Did you guys know I used to stream? Did you did know that? Yeah? Back during COVID? Pardon?
No.
Office hours, yeah. Well, it was called office hours,
what?
but it wasn't really office hours.
what?
And then people started complaining on my course evals, being like, he moved his office hours to Twitch. I'm like, no, that's just what I called it. Anyways. There. That's how we do it. You forever be remembered as doing good in the world by contributing to the GitHub repo for this class. It might seem trivial, but that's basically using GitHub to make little changes, right? You never want to do a big change. You always want to do like little changes that make sense, like functional unit changes. Something like that, simple, but you're familiarizing yourself with it. If any of you following along today or at home, you make your pull request to take your own topic, awesome, good job, I love it. See if you can get it working, right? I'm not quite sure what went wrong, but when we're put on the spot, we always kind of fumble like that, right? Trying to think what else. Let's get off his page to not alienate him anymore. Yeah. So what you will do, other things you're going to want to do is, so for your student lectures, you're going to submit it as a pull request so it goes on the website. And you're going to lecture as if it's on the website. If you also do decide to do a presentation for your final project as opposed to just like a write-up, you would do it like that as well through a pull request. Getting used to using GitHub, like it or not, you're going to want to get used to using GitHub because if you're doing more computer science outside of university, you're going to be using a lot of GitHub or GitLab or some variation of, right? What else do I want to say? Yeah, I think that's about it. Anyways, any last questions before we wrap up for today? All right, cool. Awesome. I'll see you tomorrow.